do one simple thing. Listen carefully to every single word. I guarantee 80 to 90% of this topic will be ready in your mind right now. Physics is actually very easy.
Satellites in orbits. Natural satellite, artificial satellite, launching a satellite. All of these we will learn through this simple activity. All of these, natural satellite, artificial satellite, launching a satellite, orbits, all of these we will learn through this simple activity. This is very easy and simple. In this activity, this ball represents the sun, this ball represents the earth, and this smaller one represents the moon. Now, as we know that the earth is 109 times smaller than the sun. I'm repeating, the earth is 109 times smaller than the sun in accordance to the diameter, and the moon is about 4 times smaller than the earth. Now, before we start the lecture, some questions that often comes in the student's mind. For example, if the earth is round, this ball represents the earth and earth is round. So the question is, if the earth is round, then why it looks flat to us? I'm repeating the question. If earth is round, then why it looks flat to us? For the answer, look here. If I take this small part of this round or circular line, this small portion looks straight, almost straight. Another small part, if I take this one, this small portion also looks straight. In the same way, normally we only observe the small portion of the earth. Small portion looks straight. Even this line is not straight, it's round. This small portion looks straight. This small portion looks straight. In the same way, we only observe the small portion of the earth normally. That's why it looks straight to us. Hope you got it. Actually, the earth is round, but it looks straight because we only observe the small portion. Same like to this small portion of this line. This circular line, the small portion of this circular line looks straight. In the same way, the small portion of the earth looks straight to us even though the earth is round. Hope you got it. Now the second question. If the earth is round, then why? Why don't the people on this side, on this side, on this side fall off the earth? I'm repeating the question. If the earth is round, then why don't the people on this side and on this side fall off? For the answer, look here. I have a magnet. I have a magnet in my hand. If I place this nail on the upper side of this magnet, it sticks. If I place on the bottom, it also sticks. It doesn't fall off. If I place this nail on this side, it doesn't fall off on this side. still it doesn't follow. In the same way, the people living on this side of the earth doesn't follow, because earth attracts everything towards its center. Same like to this magnet. This magnet only attracts metals, some metals, but the earth attracts everything towards its center. That's why the people living on this side, on this side, on this side doesn't fall off. Hope you got it. Now, how day and night comes? Another question. How day and night, how do day and night happen? For the answer, look here. This is the earth. The question is, how do day and night happen? Look here, this is the sun and this is the earth. This side of the earth has daytime because the sunlight hits this side, not this side. This is sun, this is the earth. The sunlight hits this side of the earth, so this side has daytime and this side has night time. Hope you got it. So an earth rotates like this, and earth completes one rotation in 24 hours. Look at this red mark. Earth rotates like this and earth completes one rotation. Now it is completed. Earth completes one rotation in 24 hours. That's how day and night occurs. When earth, right now this side has daytime, the countries on this side of the earth have daytime and the countries on this side of the earth have nighttime, because the sunlight hits, the light of this sun hits this side of the earth, not this side. Nighttime, daytime. Now at this side, as it spins, this side is getting sunlight, means morning time, and this side of the earth getting darker, means evening time. Same this, then day, and then this is how day and night occurs or happens. Now earth spins and earth also orbits around the sun. Earth has two types of motion. The first one is spin motion and the second motion is orbital motion. This path of the earth is known as orbit and the motion in the orbit is known as orbital motion. Earth has spin motion as well as orbital motion. So earth revolves like this, spin plus orbital, this like this, spin plus orbital, and earth completes one orbital revolution in 1 year. Earth completes one orbital revolution around the sun in 1 year and one spin motion in 24 hours. Hope you got it. Now this is how day and night occurs. Now an earth is a planet and moon is a satellite. How? Moon revolves around the earth and earth revolves around the sun. That's why earth is planet and moon is satellite. What is planet? Define planet. What is planet? The object that revolves around the sun is known as planet. The object that revolves around the sun is known as, in simple word, is known as planet. Earth revolves around the sun, so Earth is a planet. Earth is a planet. There are many planets: Mars, Jupiter, Pluto, Mercury. There are many planets, but Earth is also a planet. They all revolves around the sun. What is satellite? The object that revolves around the Earth is known as satellite. Moon revolves around this Earth. Moon revolves around the Earth. So Moon is a satellite, but it is a natural satellite. Moon is a natural satellite. Now, what is solar eclipse or Suraj Grahan? When, as we know, Moon revolves around the Earth. When this Moon comes during the revolution, comes between Earth and the Sun. When this Moon comes between the Earth and the Sun, this is known as solar eclipse. At this time, this looks reddish, like this. As look at my thumb, it looks reddish. Now, not reddish, no, reddish, because it blocks the flashlight of this mobile. In the same way, when this moon blocks the sunlight, it looks reddish, like my nail. So this is known as solar eclipse or Suraj Grahan. What is solar eclipse? When moon comes between the Earth and the Sun, and moon blocks the sunlight partially or completely, then it is known as solar eclipse. Now, what is lunar eclipse or Chand Grahan? When during the revolution, the earth comes between the moon and the sun. It is known as lunar eclipse. Now the earth blocks the light of the sun to reach the moon. Earth is planet. Look here. Planet means earth. Planets mean earth. There are many planets, but here remember this: planet means earth in simple way. Now look at this definition of satellite. A satellite is any object that revolves around a planet. Planet means that revolves around a earth. Look here. Satellite is any object that revolves around a planet. Any object that revolves around a planet or earth. Earth is a planet that revolves around the earth is known as satellite. Moon revolves around the earth, so moon is a satellite, but it is a natural satellite. Now, that revolves around a planet due to the force of gravity. What is the force of gravity? The force of attraction between the masses is the force of gravity. The force of attraction between earth and the moon due to the force of gravity. Now look here, moving in a stable path called an orbit. This is the definition of orbit from here to here. Moving in a stable path is called an orbit. Moving in a stable path. This stable path is known as orbit of the moon. And this path, this black path, is known as the orbit of the earth. So this stable path is known as orbit. Hope you got it. Definition of a satellite. This is the definition of satellite. Now, natural satellite. Moon is the natural satellite. The example is moon. Natural satellite, the example is moon. What is natural satellite? Look at the definition. A natural object that revolves around a planet. Planets mean earth, that revolves around a earth. A natural object that revolves around a planet. This natural object that revolves around a planet or around a earth, this is earth, is known as natural satellite. No, now planet, what is dwarf planets or minor planets? What is dwarf planets? The planet that doesn't have the fixed orbit. For example, Pluto. So Pluto is the dwarf planets. And what is minor planets? The big rocks in the space that revolves around the sun is known as minor planets. In simple way, natural object that revolves around a planet, that revolves around a planet in simple. Where, this is important, where larger body's gravity dominates the system. What does it mean? Where larger body's gravity, look here, where larger body, this is the larger body and this is the smaller, where larger body's gravity dominate the system. Dominate means run the system, control the system. In simple word, larger body's gravity run the system, control the system. So this is the dominates means control or run. Where larger body's gravity dominate the system is known as natural satellite. So example, moon is a natural satellite. 6 major planets have natural satellites. There are many planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, many planets, dwarf planets, minor planets. So 6 major planets have natural satellites, commonly called moons. Now, what is artificial satellite? Look here. First, what is artificial satellite? Consider this an artificial satellite. This is on Earth. How we will put this satellite into the orbit around the Earth? Look here. First, we will move this planet, launching a satellite to put a satellite into the orbit. To put this satellite into the orbit, first satellite is taken to a high altitude. First, this satellite is taken to a high altitude. This satellite is taken from the Earth to a high altitude to some height by using rocket. Then given a high tangential speed using rockets. Then given a high tangential speed. High tangential speed is this, in this direction. Tangential speed is the speed which is perpendicular to the radius. First taken to a high altitude, then given tangential speed. When tangential speed is given, this satellite will move like this. Why? Because of the force of attraction, it will move in this way. Now, at low speed, the satellite falls back to the Earth. At low speed, if this tangential speed is slow or low speed, then this satellite will move like this and will fall back on the Earth. At low speed, satellite falls back to the Earth. At low speed, it falls back on the Earth. At very high speed, satellite escapes Earth's gravity. At very high speed, if the tangential speed is very high, then this satellite will move in this way. It will escape. Escape means it will move away. It will never come back to the Earth it will be out of the control, it will escape. So very high speed, the satellite escapes Earth's gravity. Adjusted speed, satellite moves in a circular orbit forever. When the speed is adjusted at adjusted speed, this satellite moves in a circular path forever. Now, this satellite moves in a circular path for the, no, this is known as artificial satellite. Artificial satellites are the man-made satellite that revolves around the Earth. Look here. Artificial satellites are man-made satellite objects placed into orbit around the Earth. Artificial satellites are man-made objects placed into orbit. This is now placed into orbit around the Earth. Into the orbit around the Earth. Or other placed into orbit around the Earth or other celestial bodies. Celestial bodies mean the objects in this space, in simple way, around the Earth. Now, first artificial satellite launched in 1957. Thousands of satellites have been launched since then. Uses of artificial satellites. The first use, communication. We communicate through satellites. Radio signal, TV dish, etc. Number two, navigation or GPS. The map in our mobile is the use is GPS, global positioning system. Navigation or for border management, navigation system is useful for border management of different countries. GPS, global positioning system. And in our mobile, the map we use for to move from one place to other. Now the third one, for military purpose, the satellite are used to control the motion of rockets, missiles, etc. For this is military use. For scientific research, for research in space especially, the satellites are very important. So these are some uses. This is important. Satellites don't need NEED. Satellites don't need engines to stay in orbit because Earth's gravitational force provides the required centripetal force. Pay attention. This satellite doesn't need engine to stay in orbit. Earth's gravitational force the Earth's gravitational force provides the necessary centripetal force, provides the required centripetal force to stay in the orbit. And here no air. At 100 kilometers from the surface of the Earth, there is no air. But the satellites are at 1,000 kilometers from the Earth. The minimum is from 160 kilometers from the Earth. For above 100 meters, there is no air. No air, no resistive force. So no energy losses, so there is no need of engine. And the centripetal force is provided by the Earth's gravitational force. Launching a satellite, we already studied low speed, very high speed, adjusted speed. Now types of orbits. There are 4 types, main 3 types. The first, equatorial orbits. this orbit is, no, this is polar orbit. Polar orbit, this orbit is the polar orbit. This orbit of the earth is polar, and this orbit is equatorial orbit. This is equatorial orbit, and this is this one. This is polar orbit. Here north pole, here south pole. This is polar and this is equatorial orbits. Now, what is inclined orbit? The orbit between polar and equatorial, like this, is inclined orbit. And what is geostationary orbit? We will discuss geostationary orbit in detail in the next lecture, as well as the mathematical calculation for the velocity of the satellite in the orbit, especially the velocity in geostationary orbit. We will do in the next lecture.